All right, welcome back for another deep dive.
Yes, hello.
So today's topic is AWS Lambda. And I have to say, even just glancing at the documentation, it seems like we're about to get pretty deep into serverless applications.
You're right. Serverless is a pretty big deal these days, and Lambda is a really key part of that.
And from just a quick skim,
Yeah.
I noticed Lambda functions can be written in all sorts of languages.
Right.
Python, Go, even some that I haven't heard of.
It's a pretty long list.
Yeah, pretty amazing. And they can even be configured to interact with all these other AWS services. I mean, imagine you upload a PDF to your storage bucket and a function just automatically encrypts it.
Right away, yeah.
That's pretty cool.
It is very efficient.
But, you know, I have a feeling we might get ahead of ourselves.
Oh, yeah.
If we don't start with the basics.
Absolutely. Good point.
So in the simplest terms, what is AWS Lambda?
Okay, so AWS Lambda, it's an event-driven compute service.
Yep.
You can think of it as having these little snippets of code.
Okay.
And they're just waiting there until a specific event happens, and then they spring into action.
So it's not about having these servers running constantly. It's just little bits of code.
Yeah, and you only use computing power when you actually need it.
I see, okay.
And that need is determined by events.
So I think I'm starting to see the picture here.
Yeah.
It's not about managing servers. It's about defining actions that are triggered by specific events.
That's a great way to put it.
Now, I know the documentation mentioned an example using Amazon S3.
Oh, yes.
Which is their cloud storage service.
Yeah.
Could you kind of walk us through how that works?
Sure. So imagine you upload a file, like, that PDF we were talking about, to an S3 bucket.
Yeah.
Well, you can set up a Lambda function to automatically trigger and encrypt that file as soon as it's uploaded.
Okay.
That's the magic of it.
That's how all the pieces fit together.
Exactly.
That's pretty cool. It is. But I have a feeling that there are probably some key concepts that we need to really understand before we can even really grasp how to use this stuff.
Absolutely. You need a good foundation.
So what are some of the crucial things to know about Lambda?
Okay. So one of the most important concepts is the handler.
Handler. Okay.
It's basically the entry point for your code.
Okay.
It's the specific function that AWS Lambda calls to start executing your instructions.
Ah, so it's how Lambda knows where to begin.
Exactly.
Okay. And what about the environment where this code runs?
Right. So that's called the execution environment.
Okay.
And it's a secure and isolated space specifically for your function. And the great thing is AWS manages this entire environment.
Oh, so no more server headaches.
You got it. No servers for you to manage.
It's pretty nice.
It is very convenient.
So how do we connect these events, these real-world events, to our Lambda functions?
Okay, well, for that we have triggers and event source mappings. Triggers are like direct calls to your function, while mappings are more like these constant watchers that check services like queues for any new items that need to be processed.
I see.
Yeah.
But how does the function know what to do with this event?
Right, it can't read our minds.
Yeah, exactly.
Well, that's where the event object comes in.
Okay.
It's basically a package of information, usually formatted in JSON, that gives the function all the details about the event that triggered it.
Can you give an example?
Sure. Remember the S3 file upload we were talking about?
Yeah.
Okay, so the event object would tell the function which bucket the file landed in, the name of the file, the size, even who uploaded it.
I see. So it's like giving the function all the context it needs.
Exactly. It's a briefing packet.
Okay, cool.
Yeah.
So the function is set up. It gets triggered by an event.
Right.
It gets its event object with all the details. What happens then?
Well, it can't just run wild and do whatever it wants. Like any other program, it needs permissions to interact with other services.
Makes sense.
And that's where the execution role comes in.
Okay.
It defines what the function is allowed to do.
So we're making sure it plays by the rules.
Exactly. Keeping everything secure.
Okay, well, this is a lot to take in.
Yeah, we've covered a lot.
My brain needs a moment to process this.
I hear you.
But before we do, can we talk about what actually happens during the execution of a Lambda function?
Oh, sure.
It's just like one and done. It just runs once and that's it.
It's a bit more dynamic than that, actually. Right. There's something called the Runtime Environment lifecycle, which involves a few different phases: initialization, invocation, and shutdown. And what's interesting is if a function crashes, Lambda actually resets the environment automatically, so it's ready to try again.
So it's kind of self-healing.
Exactly. Reliability is key.
Wow, that's impressive.
It is a very resilient system.
Okay, but we're not just talking about individual functions.
Yeah.
This is all part of something bigger.
Yes, this is all part of event-driven architecture.
Okay, so how is this different from how applications are usually built?
Well, in a traditional application, you're often constantly polling for updates, which can use a lot of resources and be slow.
Right.
But with event-driven architecture, you're reacting to events in real time.
Okay, so it's more efficient.
Much more efficient and much more responsive.
And I'm guessing there are some potential pitfalls.
Oh, of course. There always are.
Like, what are some mistakes people make when they're first starting out with this?
One common mistake is creating these giant monolithic Lambda functions.
Right.
It's like trying to cram everything into a single room.
Yeah, that doesn't sound very efficient.
Not at all. It gets messy quickly.
So what's the best approach then?
It's better to break things down into smaller, more focused functions.
Okay, so divide and conquer.
Exactly. That's the strategy.
Now, the documentation also mentioned some best practices, specifically for organizations. Using Lambda.
Yeah.
What are some of the key takeaways there?
One important tip is to use multiple AWS accounts to manage your quotas effectively.
Oh, so you don't hit any limits.
Exactly. Separate accounts give you more breathing room.
And are there any other best practices that stand out?
Yes. Another one is using services like DynamoDB or Amazon EFS to retain state between function invocations.
This is like giving your functions a memory.
Exactly, so they can remember information from previous runs.
I see. That makes sense.
It can be very useful for certain types of applications.
Okay, we've covered a lot of ground here.
Yeah, we have.
From the basic definition of Lambda to event-driven architecture and even best practices for organizations.
Absolutely.
It's all starting to come together.
Good. I'm glad to hear that.
But now, I think it's time to look at a concrete example.
Okay.
And I know the documentation provides a perfect one. That PDF encryption scenario that we keep coming back to.
Oh, right. That's a good one.
Yeah. So let's break that down and see how all these concepts play out.
Let's do it.
So we have a user uploading a PDF to an S3 bucket.
Right.
And we want to encrypt that file automatically.
Yeah.
What are the main components involved in making this happen?
Okay. So first, you have the S3 bucket itself, where the file is uploaded.
Okay.
Then you have your Lambda function, which in this case would be written in Python to handle the actual encryption process.
Right.
And finally, we need IAM permissions.
Right. For security.
Exactly. To make sure the function can access and modify the S3 bucket.
Okay. And what does the code for this actually look like?
Well, the documentation actually includes a snippet of Python code.
Oh, cool.
And it uses this interesting library called pipdf.
Oh, what's that?
It's a library that makes it easier to work with PDF files within the function.
Okay, so it's like a specialized toolkit.
You could say that, yeah.
But how do we test this?
Right. Well, the documentation emphasizes two main approaches: manual verification and automated testing.
So with manual verification, we just upload a PDF and see if it gets encrypted.
Exactly. That's the basic check.
Okay.
But for more robust testing, they recommend using automated scripts with a framework called PyTest.
PyTest, interesting.
Yeah, it's a popular tool for Python testing.
So this ensures the function always works as expected.
That's the goal, yeah.
Are there any other tools or techniques they mention that can help us build and deploy Lambda functions?
Yes. Actually, they briefly talk about AWS
SAM,
the Serverless Application Model.
Okay, I have to admit, I'm a little curious about this.
Yeah, it's a pretty powerful tool.
What makes it so special?
It lets you define and deploy your entire serverless infrastructure as code.
Infrastructure as code?
Yeah, so instead of manually setting up S3 buckets, configuring Lambda functions and all that, you write a script that does it all for you.
Hold on, so we're talking about like writing code to manage our infrastructure. That sounds intense. Is that something we need to be experts in to use Lambda effectively?
It's definitely worth exploring, especially as your serverless applications become more complex.
Okay.
But don't worry, we'll dive into SAM and how it works with Lambda in the next part of our deep dive.
Okay, you've piqued my interest.
Good.
But for now, let's just recap what we've learned.
Sounds good.
We started with a simple question. What is Lambda? And we've uncovered a whole world of event-driven architecture.
It's quite a journey.
And serverless computing and tools like SAM.
It's a lot to take in.
It is. And we've only just scratched the surface.
Oh, yeah.
There's so much more to explore.
Definitely.
So in part 2, we're going to dive even deeper into how Lambda integrates with other AWS services.
Sounds good.
And how you can optimize its performance.
I'm looking forward to it.
Don't go anywhere. We'll be back with more insights in a flash.
See you soon. Welcome back. Okay, so
in the last part, we covered some of the fundamentals of Lambda.
Now let's talk about how Lambda interacts with the rest of AWS.
Okay.
I mean, Lambda functions are not really islands.
Right.
They can do so much more when you connect them with other services.
So what kind of integrations are we talking about?
Well, take DynamoDB, for instance.
Yeah.
That's Amazon's NoSQL database service.
Yeah.
You could set up a Lambda function to trigger whenever data changes in a DynamoDB table.
So real-time data processing.
Exactly. You could update other systems, send notifications, or even start more complex workflows automatically.
So Lambda's kind of like the glue.
Yeah, it's a good analogy.
That holds everything together.
It connects different parts of your AWS infrastructure and reacts to changes in real time.
What other services can it integrate with?
Oh, tons. SQS for queuing messages, SNS for notifications, Kinesis for processing real-time data streams.
Wow. The possibilities seem endless.
They really are. It's incredibly versatile.
This is giving me all sorts of ideas.
I bet.
But I think it would help to see a specific example.
Of course, yeah.
And I know the documentation mentions a really good one using EventBridge Scheduler.
Oh, yeah, that's a good one.
I remember you mentioned that before.
Mm-hmm.
It's supposed to help us avoid those clunky cron jobs.
Exactly.
Can you remind me how it works?
Sure. Imagine you need to, say, clean up an old DynamoDB table.
Nope.
Instead of doing it manually or setting up a cron job,
Yeah.
you could just schedule it with EventBridge Scheduler.
Mm.
And then trigger a Lambda function to handle the actual cleanup process.
So it's like setting a reminder.
Kind of. Yeah.
But instead of a sticky note, it's this powerful cloud-based system.
Right. And it integrates seamlessly with your Lambda functions.
That's really neat.
It is.
But with all this power, are there any security risks?
That's a good question.
Yeah.
Security is super important with serverless.
Of course.
AWS has a lot of ways to protect your functions.
Okay, like what?
Remember those execution roles we talked about?
Yeah.
They're crucial for controlling what a function can and cannot do.
So we can limit what the function can access.
Exactly. You set boundaries to prevent unauthorized access.
Makes sense. Are there any other security measures?
Oh, definitely.
Like what?
AWS also gives you tools for monitoring your functions,
Okay.
tracking performance, and detecting suspicious activity.
So it's like having a security camera,
It's a good way to think about it.
watching over everything.
Exactly. Keeping everything safe and sound.
Now, there's this phrase that keeps popping up.
Mm-hmm.
Infrastructure as code.
Oh, yeah.
Can you explain what that means?
Sure. It's basically a way to manage your IT infrastructure using code.
Instead of clicking around in a web console.
Exactly. You write code to define your setup.
What are the benefits of doing that?
Well, you get all the advantages of software development for your infrastructure.
Oh, like version control and automated testing.
Exactly. And repeatable deployments.
So it makes everything more reliable.
Much more reliable and less prone to human error.
Okay, so how does this relate to Lambda?
Well, your Lambda functions are part of your infrastructure. So with infrastructure as code, you can define them in your code, too.
Their triggers, their integrations, everything.
Exactly. You manage it all in one place.
Are there specific tools for doing that with Lambda?
Yes. AWS has tools like CloudFormation
Okay.
and SAM, the serverless application model.
Right,
They make it really easy to define your whole serverless application.
including Lambda functions.
Yes, everything.
Okay, I'm definitely adding SAM to my list of things to check out.
It's a great tool.
But before we move on,
Yeah.
I want to talk about optimizing Lambda performance.
Oh, good point.
Speed and efficiency are super important, right?
Absolutely, especially in a serverless environment.
So how do we make our Lambda functions run faster?
Well, one important factor is memory allocation.
Okay.
The more memory you give a function, the more CPU power it gets.
So more memory equals better performance,
Generally speaking, yes.
but probably higher cost too, right?
That's the trade-off. You have to find the right balance.
How do we do that?
Well, it depends on the complexity of your code,
Mm-hmm.
what libraries you're using, whether you're accessing external resources.
Okay.
But AWS has tools to help you analyze performance and find the optimal settings.
So we can fine-tune everything.
Exactly. You can even use Compute Optimizer.
What's that?
It analyzes how your function is being used
Excellent.
and recommends memory settings based on that.
It's like a personal trainer for your Lambda functions.
I like that analogy, yeah.
But what about the code itself?
Oh, right. The code itself is important too.
Can we optimize that for performance?
Absolutely. You can minimize external dependencies, streamline your logic, and even use caching mechanisms
to store frequently accessed data.
Exactly. All of that can help.
Are there any other performance factors to consider?
Yes. The guide also mentions something called ephemeral storage.
What's that?
It's basically temporary storage that your function can use.
Okay.
It's separate from the usual TMP directory.
So it gives the function more space to work with.
Exactly, especially if you're dealing with large data sets.
That makes sense.
It can make a big difference.
What about the choice of runtime?
Oh, that matters too.
We've been talking about Python a lot.
Right.
But what about Node.js or Java?
Yeah, Lambda supports a lot of different languages, and they all have their own performance characteristics. Like compiled languages tend to be faster than interpreted languages.
So the choice depends on the application.
And your team's expertise, yeah.
Are there any universal tips for optimizing performance, regardless of the language?
One thing to watch out for is cold starts.
Cold starts?
It's the initial delay when a function is invoked for the first time.
Or after a period of inactivity.
Right. It takes a moment for everything to spin up.
Okay.
And for some applications, that delay can be significant.
So how do we minimize those cold starts?
There are a few strategies.
Like what?
You can keep your functions warm by invoking them periodically.
Okay.
You can optimize your initialization code. And you can even use something called provisioned concurrency.
What's that?
It basically keeps execution environments ready to go.
So no more waiting around.
Exactly. Your functions are always ready to respond.
Okay, I'm feeling much more confident about working with Lambda now.
Good. I'm glad to hear that.
We've covered integration, infrastructure as code, performance optimization, even those pesky cold starts.
We've gone pretty deep.
We have, but there's still more to learn.
Oh, absolutely.
In Part 3, we'll get into specific programming languages.
Sounds good.
And explore some common pitfalls and troubleshooting tips.
I'm looking forward to it.
Stay tuned. We'll be back with more insights soon. All right, welcome back. So far in our Lambda deep dive, we've tackled the basics, explored integration, even talked about performance optimization.
We've covered a lot.
But now I'm really interested in seeing how all of this translates into actual code.
Okay, yeah, let's get into the languages.
The documentation covers quite a few.
It does.
But let's focus on a few key ones, shall we? Node.js, Python, and Java.
Sounds good.
Let's start with Node.js.
Okay.
Since I'm a bit of a web developer myself, what are the essentials for using Node.js with Lambda?
Well, the first thing to understand is that Node.js in Lambda runs in a specific execution environment.
So it's not just our typical Node.js setup?
Not exactly, no.
Okay.
This environment includes the Node.js runtime itself and a bunch of libraries and tools that are specifically for Lambda functions.
I see.
And one of the really important things to understand is how the Node.js event loop works within Lambda.
Right, the event loop. That's like the heart of a Node.js application, right?
Exactly. It handles all those asynchronous tasks that Node.js is known for.
Yeah, all those things happening at the same time.
Right.
Without blocking each other.
Precisely. But in Lambda, you have to make sure those tasks finish properly before the function ends.
Oh, right. Otherwise, we could have problems.
Exactly. You might get incomplete operations or unexpected results.
Okay, so how do we manage those asynchronous tasks effectively in Lambda?
The guide offers some great tips.
Oh, good.
Including ways to wait for those tasks to finish before sending back a response.
So it's all about making sure everything wraps up neatly.
Exactly. Keep that event loop happy.
Now, how do we actually get our Node.js code into Lambda?
Well, there are a couple of approaches for deployment.
Okay.
One common way is to use .zip file archives.
Okay.
You basically bundle your code and all its dependencies into a single file.
So it's like packing a suitcase for our code.
Yeah, good analogy.
Making sure it has everything it needs for its trip to the cloud.
Exactly. And the guide even talks about using command line tools and build automation tools like sbuild to make that process more efficient.
Sbuild, yeah. I've heard that's super fast.
It is. And speed is definitely a good thing when it comes to deployments.
Absolutely. The faster, the better.
For sure.
Okay, so besides .zip archives, are there other ways to deploy Node.js functions?
There is another increasingly popular method. Using container images.
Oh, Docker containers.
Yes, exactly.
But I thought Docker was more for, like, big applications.
Traditionally, yes.
Not these small functions.
It was, but with serverless becoming more and more popular, Docker's become a great tool for Lambda functions, too.
Okay, how so?
Well, it lets you package specific versions of Node.js and all your libraries and even operating system dependencies.
So everything is self-contained.
Exactly. You're basically shipping your function in its own little world.
That's pretty cool. And does AWS support this?
Oh, yeah. They have great support for deploying Lambda functions as Docker containers.
All right, so we've covered Node.js deployments. Now, let's switch gears and talk about Python.
Okay, yeah.
What are some things to keep in mind when using Python with Lambda?
Much like with Node.js, it's important to understand the Python execution environment.
So AWS provides a specific environment for Python as well?
Yes, they do.
Okay.
It includes the Python interpreter, the libraries, and tools to interact with AWS services.
All right, but are there any Python-specific things we need to be aware of?
One key thing is managing dependencies.
Okay.
Unlike a regular Python application where you can just install libraries freely, with Lambda, you have to package those dependencies with your code.
I see. So it all has to go together.
Exactly. It's like bringing your own toolbox.
And how do we manage those dependencies?
One common way is to use virtual environments.
Right, virtual environments. I know those.
They basically create an isolated space to install your libraries without causing conflicts.
So it keeps everything nice and tidy.
Exactly.
Okay, so once we have our virtual environment and all our libraries, what's next?
You package everything together, code and dependencies, into a deployment package.
Usually a .zip file.
Exactly. And the guide even mentions some tools that can automate that process.
Okay, so our Python code is packaged and ready. Now, what about logging and monitoring? How do we keep an eye on things?
That's where Amazon CloudWatch comes in.
CloudWatch, again.
It's a powerful tool.
I'm sensing a theme here.
You can configure your functions to send log messages.
Okay.
And CloudWatch captures and stores them.
So it's like a logbook for our functions.
That's a good way to think about it.
And if something goes wrong, we can look at those logs and see what happened.
Exactly. It's great for troubleshooting.
Can CloudWatch do anything else besides just collecting logs?
Oh, definitely.
Like what?
You can create dashboards to visualize your data.
Okay.
Set up alarms to notify you of specific events. Even define custom metrics to track how your function is performing.
Wow. It really is a complete monitoring solution.
It is very comprehensive.
Okay, so now I'm feeling much better about deploying Python code to Lambda.
Good.
I know we can monitor everything and troubleshoot any issues that come up.
That's the goal.
Now, before we wrap up our language tour, let's talk about Java.
Okay.
It's a big player in the enterprise world.
Huge.
But does it make sense to use it with Lambda?
It does, yeah.
Well.
Just like with Node.js and Python. There's a managed execution environment for Java in Lambda as well.
So everything's pre-configured.
Right. It includes the Java virtual machine, the core libraries, the AWS SDK for Java.
So we have everything we need.
Exactly. You can hit the ground running.
But Java can be pretty complex.
It can be. Wow.
What do we need to know about packaging and deploying Java code for Lambda?
Well, it's a bit more involved than with other languages.
Okay.
Java applications typically involve compiling code into .class files and then bundling them into JAR files.
Right, Java archive files.
Exactly. So for Lambda, you need to create a deployment package that includes all your compiled code and dependencies.
So it's like taking our whole Java project and sending it up to Lambda.
That's a good way to think about it.
Okay. How do we create this deployment package?
The guide suggests using build tools like Apache Maven or Gradle.
Okay, I've heard of those.
They're pretty popular in the Java world.
Yeah.
They handle all the complexities of compiling, resolving dependencies, and creating that final deployment artifact.
All right, so packaging and deployment are handled.
Yeah.
Well, what about the Java code itself? Are there any specific tips for writing Lambda functions in Java?
The guide highlights a few key things.
Like what?
One is the use of handler methods.
Okay.
Which are basically the entry points for your function.
So that's where the Lambda runtime knows where to start executing the code?
Exactly. They receive the event object, process it, and then return a response.
And does the AWS SDK for Java help with this at all?
It does, yeah.
How so?
It provides interfaces you can implement to define those handler methods.
So it makes sure our code interacts correctly with Lambda?
Right. It streamlines the process.
Are there any other Java-specific tips?
The guide emphasizes optimizing your code for the Lambda environment.
Okay.
Remember, cold starts.
Oh, right. That initial delay.
Exactly. So minimizing the startup time of your Java function is crucial.
Makes sense. Every millisecond counts.
It really does.
So how do we speed things up?
The guide suggests minimizing dependencies, using lazy initialization, and even leveraging tools like AWS Lambda Power Tools.
Power Tools. What are those?
It's a set of utilities that can help streamline common tasks.
Oh, interesting.
And improve the efficiency of your Java Lambda functions.
Okay, I'm adding that to my to-do list.
It's a good one.
Wow, this has been an incredible journey.
It has.
We've explored so much about AWS Lambda.
From the fundamentals to the nitty-gritty details of different languages.
It's not just a service, it's a whole new way of thinking about software development.
I completely agree. It's a paradigm shift.
And that's what's so exciting about it.
Absolutely.
It's a technology with so much potential.
Limitless possibilities.
So to our listeners, I hope this deep dive into AWS Lambda has been insightful.
I hope so.
And inspiring.
Yeah.
Don't be afraid to experiment, push those boundaries, and see what you can create.
That's the spirit.
In this exciting world of serverless computing.
It's a great time to be a developer.
It is indeed.
Until next time.
Happy coding, everyone.